Good morning to all. It is so nice to speak to you all, my little learners. This time I was thinking how to plan to teach you all online. And I tried to make the interactions as easy as I could. If still you have any problem, you may ask me in the comments below. I will try to solve them. So today I begin with the first chapter, force. So let us move to the other slides to see what is there in the chapter. So, what is force? You have studied in your earlier classes that force is a push or pull observed in a body. You have also studied that force is any interaction that, when unopposed, will change the motion of the object. That means if the body is rigid, if the body is solid, then there will be a change in motion of the body. And if the body is non-rigid, then there will be a change in the shape and size of the body. So there will be three kinds of changes when force is applied on an object. Number one, there will be a change in motion of the body. What is motion here? That means if a body is at rest, the body will start moving when force is applied on it. And if the body is moving and force is applied, the body will come to rest. That means any body which has mass and force is applied to it, there will be a change in its velocity. Either it will accelerate, that means it will start moving, or it will decelerate, that means it will come to rest or negative acceleration. You have studied all this in class 9. Then you have also studied that force is a vector quantity. What does a vector quantity mean? You all know that it has magnitude as well as direction. It depends on magnitude as well as direction. And the SI unit of force is Newton. And you know one more unit, that is MKS unit, that is kg meter per second squared. Okay, so right now we studied that if unopposed, force brings about a change in motion, in shape and size, and in direction. So if the body is rigid and is acted upon by force, it shows two kinds of motion. So in the next slide, we are going to study the kinds of motion when a rigid body is acted upon by force. So the first kind of motion is linear motion or translation motion. Now what is this? Suppose a body is there and force is applied on a body. The body is not fixed. The body can move in any direction and force is applied on this body. The body will move in a straight line. It will move in the direction of the force. So when a body is free to move, it starts moving in the direction of force. And this kind of motion is known as linear motion or translation motion. The second kind of motion is rotational motion. The condition here is that the body is fixed at a point. At some point, the object will be fixed, pivoted at some point. And force will be applied at some position on the object and the object will start moving. As in the examples you can see, in the first one, the force is applied and you can see how the body is rotating around the fixed axis. In the second figure, you can see it is fixed from the center and the force has been applied and it is going in circular manner. And in the third one, you can see it is the opening of a door. It has been pivoted or hinged from one point, and when force has been applied from other point, then the door opens. It moves. It moves in circular manner, and this is known as rotational motion. So we have studied two kinds of motion. One was when the body is not fixed at any point and force is applied, that is linear motion or translation motion. And second, when the body is fixed at a point and force is applied to some point on the object, then the body starts moving in circular manner, rotatory manner, and this kind of motion is known as rotational motion. Now we are going to study turning effect of force. This is known as moment of force or torque. So turning effect of force, there are two conditions to be applied in this. The first one, the body should be a rigid body. If it is not rigid, then there will be a change in shape and size. We have already studied. So the condition is that it should be a rigid body. And the second condition is that it should be pivoted at some point. That means it should be fixed at some point. And these are the two conditions for having a turning effect of force on an object. Now, moment of force or turning effect, there are some factors which affect the turning of body. The first one is magnitude of force applied. Now, the amount of force applied on a body will decide that the body will rotate or not. And the second thing, the perpendicular distance from the fixed point to the line of action of force. So these two factors are very important. So moment of force is, if I talk about the magnitude of moment of force, then it is the product of force applied into the perpendicular distance from the fixed point to the line of action of force. In these examples below, we see that there is a wrench and force has been applied from the place. You can see the blue arrow and the distance that when it is opening the nut, the distance from the line of action of force till the fixed point, you can see that is the perpendicular distance, and force into this perpendicular distance will give you the moment of force of this object. The second one, you can see there is a door which is hinged from one place and force has been applied from the other. So the distance between the hinge and line of action of force, that will become the distance, that will become the perpendicular distance, and the magnitude of force applied will give you the moment of force. So when force is multiplied by the perpendicular distance between the fixed point and line of action of force, then we get moment of force or torque. We go to the next slide. So we studied in the last slide that moment of force is the turning effect and the magnitude of moment of force is force into the perpendicular distance from the fixed point till the line of action of force. Now, when will the turning effect be maximum? Either the force should be maximum or the distance should be maximum. Now, it is easy to increase the distance. It is easy to increase the perpendicular distance. If we talk about the example which is given below, the person is opening the door. It has been hinged from the place. You can see the blue line that has been the fixed point. Now, if you hold the door from the handle which is given to open the door, then that will be the maximum distance from the fixed point. And if you hold the door from somewhere very close to it, it will be difficult to open and close the door. So it will be difficult to give a rotation to the door. So when is the turning effect maximum? When the distance from the line of action of force and the fixed point is maximum. Okay, now one more thing, that the force applied from anywhere on the object will not have a turning effect. For example, if you see the second example, you can see force F1, you can see force F2, and you can see force F3. Now, force F1 is being applied at the fixed point. Can you see that? It has been applied at the fixed point and in the direction only. If you are holding a pen, and if you are holding a pen from one hand and from the second hand, you apply force in the direction of pen only. Will the pen rotate? No. And the second case, that is F2. If you hold the pen and from the point from where only you are holding the pen, you are applying the force from that point only. Will the pen rotate? No. It has been fixed from there only, and if any force is applied at that point, it will be zero. Why? Because the distance from the fixed point will be zero. At pivoted point only you are applying the force. The distance between the pivot and line of action of force is zero, and therefore there will be no rotation. The rotation will only be possible if it is between anywhere from the pivoted point to the maximum distance, which we have already spoken about. Okay, so we have studied moment of force, that is the turning effect of the force, torque, which is force into the perpendicular distance, and you know when the turning effect will be maximum. So we go to the next slide. So now we come to couple of forces. What is a couple? Two equal and opposite parallel forces not acting along the same line form a couple. Now let us understand this, that what is the importance of this and why are we studying. So when we talk about normal moment of force, a single force applied does not cause rotation. Try to understand. A single force applied will not cause rotation. Rotation is always produced by pair of forces. Now, let us take one example. All the examples which have been mentioned above, the rotation is due to the externally applied force. But you know that every action has equal and opposite reaction. So, every externally applied force gives a reactionary force, which is produced at the pivoted point, at the fixed point. So, it creates a couple of forces. Force of reaction is equal in magnitude and opposite in direction. So, this forms the couple. the moment of force of reaction about a fixed point is 0 because the distance from the axis of rotation is 0. That means what we are talking about, the reactionary force. Why is the moment of force for the reactionary force 0? Because it is being applied at the fixed point only, and the distance from the fixed point and reactionary force is 0, and therefore the moment of force is also 0. So in all the cases which we have studied till now, there was an external force, and in reaction to this, there was a reactionary force, and these two together formed a couple of forces. So now, suppose we take a meter rule and we fix it from the center. That is, in the diagram, if you see, we have fixed it from center O, that is 50 centimeter. Now, let one end be A and the other end be B, and let equal forces be applied at A and B. Now, moment of force you have studied is force into displacement, perpendicular distance. So, moment of force at A will be F into OA. That is, F is the force and OA is the distance from the fixed point to the line of application of force. So F into OA. Then moment of force at B will be F into OB. So total moment of force will be F into OA plus F into OB. Now why are we adding? Now one thing you have to know here is that the clockwise moment, any rotation which is clockwise, the moment will be taken as negative. Whereas any anti-clockwise rotation, the moment will always be positive. Please remember, as in mathematics also, in the graph copy also, when you go anti-clockwise, that is positive, and when you go clockwise, that is negative. The same way, here also, anti-clockwise is positive and clockwise is negative. So here we can see the direction of force. You can see the direction of force, that is anti-clockwise. Therefore, the moment of force at A is also positive and moment of force at B is also positive. And so total moment of force will be added. So it will be F into OA plus F into OB. Now F will be taken common, OA plus OB, and that becomes F into D. And the complete rotation is anti-clockwise because the result is a positive. So you have studied till here, that is what is couple of forces and what is the total moment of force on any body. So we take the next slide. Now in this slide we have studied this earlier only. When it is clockwise moment, it is always taken as negative, and when it is anti-clockwise moment, it is always taken as positive. Here you can see two diagrams. The circle is moving. In the first case it is anti-clockwise, and in the second case also anti-clockwise. Both the forces along, that is the couple of forces, are making the body move anti-clockwise. Clockwise. Both the bodies are moving clockwise. Now in this slide we have a numerical. Most of your numericals are based on meter rule only. Meter rule, that is 100 centimeter ruler. So in this diagram we can see that there is a meter rule. It is fixed. You can see that triangle, that is the fulcrum, that is a fixed point. F1 is the force which is being applied downwards, and the force magnitude of force is 20 kgs. And it is applied at 10 centimeters. At 10 centimeters, that is from 0, then at 10 centimeters, this force has been applied. And F2, The magnitude of F2 is 30 kgs and is applied at 70 centimeter mark on the meter roll. The question is, what is the net moment of force? Now, clockwise and anti-clockwise moment I have already taught you. So, first we will calculate the anti-clockwise moment. So, moment is force into the distance. So, F1 into D1 about the first one. So, that will be 20. That is the magnitude of force, and the distance between the fixed point and line of action, it is at 10 centimeter mark, and the fulcrum is at 50 centimeter. So 50 centimeter minus 10 centimeter makes it 40 centimeters. So 20 kg into 40 centimeters makes it 800 kgf centimeters anti-clockwise. Clockwise, F2 into D2. Now F2 is 30 kgs and D2, that is, it is at 70 centimeter mark and fulcrum is at 50 centimeter mark. So 70 minus 50, that makes it 20 centimeters. So 30 into 20, that gives 600 kgf centimeter. Now net moment, anti-clockwise will be positive and clockwise will be negative. So 800 minus 600, in total we have 200 kgf centimeter, and the body will move anti-clockwise. Now whichever side the force will be more, the body will move in that side only. So net moment here is 20 kgf. So we go to the next slide. Now we have another question. We have to find out the net moment of force about the fixed point. Fixed point is S over here, and we have to find out the net moment of force. Force both the sides is 5 Newton and S is at 50 centimeters. That is at middle point. Now solution, it is the same as we have done right now. So you can see the bodies are moving clockwise. The force, both the forces are making the body move clockwise. So the first one, it will be minus 50. That is the distance from 0 to the fixed point is 50 centimeters this side also and 50 centimeters that side also. So minus 50 into 5 Newton, that makes it minus 250 Newton centimeter. And then again minus 250 Newton centimeter, and both will be minus and minus, so the result will also be minus. So minus 500 Newton centimeter or minus 5 Newton meter clockwise. So minus means clockwise here, and the total moment of force is 5 Newton meter. We have one more question. I had spoken about it earlier also, that when will the moment of force be maximum? That is to be applied here in this question. That is why I have taken these all are board problems. All the 3 questions which I have done is board problem. So what is the least torque when force applied on a wrench is 2 Newton and length of wrench is 20 centimeter? So solution, here I have given that force applied is 2 Newton. Now, when will the effort be the minimum? When you take the maximum distance, that means maximum distance will be the whole 20 centimeters, because the length of the wrench is 20 centimeters. So 2 Newton into 20 centimeters, that makes it 40 Newton centimeters or 0.4 Newton meter. So I hope I am clear with these numericals. I'll give you few numericals in the homework. So this, I end up with the class today. I hope you have understood something from here, and this will be a help for you. So we meet in the next class. Till then, thank you. Bye-bye.
If you like my channel, please do subscribe it. Thank you so much.